Hello and welcome to today's video where we shall be looking at relative maximum/minimum and inflection point. In our last two videos, we had dealt extensively with the following: increasing/decreasing functions, interval of increase/decrease, critical values, and critical points. In today's lesson, we shall be taking a second look at critical points. A critical point can be maximum, minimum, or a point of inflection. So, in this lesson, we shall be learning how to determine the nature of a critical point on a graph or function. Let us consider this graph, which is a graph of some function y equal to f of x. Obviously, on this graph, there are three critical points: point A, point B, and point C. And of course, they are called critical points or turning points. We want to investigate when a critical point is said to be a relative maximum or minimum or a point of inflection. Let us take the critical point A. For instance, at this point A, there is of course a corresponding critical value which I call x1. We know that at this point A, since the graph rises to point A, it means that the graph is increasing to the left side of this critical point. Since the graph increases to the left of point A, it means that the derivative or the slope of the graph to the left of A is what? Positive. And to the right of A, the graph is decreasing. And for a decreasing graph, we have learned already that the slope f prime of x is always what? Decreasing. So we observe that to the left of the critical point A, the graph always increases, the slope is positive, and to the right of the critical point A, the graph is what? The slope is decreasing or negative. So what do we say? We now say that A is called now a relative/local maximum point. So at a maximum point, there is usually a change of sign of the slope from positive to what? To negative. So if at the critical point A, you observe that to the left of that point, the slope is positive, and to the right of the point, the slope becomes negative, meaning that the slope has changed sign from positive to negative, then the critical point in question is now called a relative or local what? Maximum. Now let's look at the critical point B, which corresponds of course to the critical value, say x2. It is obvious from here that the slope to the left of this critical point is negative, since the graph is a decreasing function to the left of B. And to the right of B, the graph rises, which means the function is increasing to the right of B, which implies that the slope to the right of B, f prime of x, will be what? Positive. We observe here again that at the critical point B, the slope to the left side of B is negative, and after B, the slope to the right side of B becomes what? Positive. This makes B a relative or local what? Minimum point. So we conclude that at a minimum point, there is a change of sign of the slope from negative to what? To positive. Let's look at the point C. At the point C again, there is a critical point or a turning point. But what do we observe? To the left of C, the slope is positive. And to the right of C, the slope once again is positive. Because at C, the graph is not coming down. The graph remains an increasing graph to the right of C and is also increasing to the left of C. So we observe that at point C, the left side, the sign is positive, and the right side of point C, the sign remains what? Positive. Therefore, there is no change in sign from the left of C to the right of C. So this makes C an inflection point, or what we call a point of inflection. So, to investigate the nature of a critical point, all we need to do is to check what the signs are to the left of the point as well as what? To the right. Having in mind that at a maximum point or at a local maximum point, To the left of that point, the slope is always what? Positive. And to the right of the point, the slope becomes what? Negative. And at a relative minimum, the slope to the left is negative and the slope to the right is positive. And at the point of inflection or inflection point, the slope on the left and right remains the same in sign, such that if the slope to the left is positive, the slope to the right remains what? Positive, and vice versa. We want to now learn how to determine this critical point using what we call the first derivative test. First derivative test for extrema. Now, extrema here simply means minimum or maximum. Example, use first derivative test to determine the nature of extrema of the function f of x equal to x cubed over 3 plus x squared over 2 minus 6x plus 8. So the first thing we must do is to find what? The extrema, or rather to find the critical point of the function. After finding a critical point of the function, we'll now check if the critical points, are minimum or what? Maximum critical point, or of course, or point of inflection. So we take the first derivative, f prime of x, and that is what? That will be x squared plus x minus 6. So to get the critical point or the critical values, what do? We set the first derivative to 0. So if we set x squared plus x minus 6 to 0, we get that x equal to minus 3 or x equal to 2. This means that this function has critical points at the critical numbers x equal to minus 3 or x equal to what? 2. So now we have to determine the critical point that corresponds to these two critical values. So for the first critical value, minus 3. So f of minus 3 is equal to, so if we substitute minus 3 into the function, what do we get? We get 43 over 2. So that the critical point at this value becomes what? Minus 3 and what? 43 over 2. And to get the critical point at the critical value x equal to 2, we do the same. So f of 2 gives us what? If we put 2 into the function f of x, we get 2 over 3. This implies that the critical point, at this value, is 2, 2 over 3. So we now have two critical points for this function. The first is this, and the second is this. We now want to check the nature of the critical point. That is to say, we want to check if the critical point corresponds to a maximum or a minimum, as well as the other critical points. To do this, we sketch our x-axis. So the first critical number is minus 3. So negative 3 is somewhere here. And the second critical number is 2. And 2 is to the right of negative what? 3. We now have to check what happens to the left and to the right of each critical what? Number. That is to say, we want to check to see if the slopes of, the slope of this function will have a change in sign from left to right or from right to left, as the case may be. So we begin with the first critical number, negative what? 3. To the left of negative 3, we have minus infinity to that point. So we can pick any number on this left interval. So in this example, I choose to pick the number x equal to negative what? 4. Since minus 4 is in this interval. Now, f prime of minus 4, if you put minus 4 into the first derivative, you get 6, and 6 is positive. So this means that on the left side of this critical number, the function is what? Is increasing, since 6 is what? Positive. On the right side of the function, we pick another value, and in this case, I choose to pick the value x equal to 0 for simplicity. If x is equal to 0, then f prime of 0 gives me minus 6, and minus 6 is negative. It means that on the left side of this critical number, we have negative. So what does this mean? It means that the critical what? At this critical number x equal to minus 3, the function does what? The slope changes sign from positive to what? To negative. And we had explained earlier that At the maximum point, the slope will change its sign from positive to what? To negative. And we have seen here that at this critical value, x equal to minus 3, the slope changes sign from positive to what? To negative. So what does this imply? It implies that the critical point at this critical number, which is what? Minus 3, 43 over 2, is what then? This critical point is what? A relative or local what? Maximum. So at this point, the critical point is up. So the critical point is somewhere here. Minus 3, 43 over 2. Since the sign changes from positive to negative, so it must be a maximum. We now check also the second critical value and see what happens to the left and to the right of the point. To the left of the critical value x equal to 2, we choose again x equal to 0, same point. And we have that to the left of this critical value, the slope is negative. Now to the right of the critical value, which is from 2 to positive infinity, we pick another value. And in this example, I choose to pick the value x equal to 3. So that f prime of 3 is what? Is 6. Is equal to 6. And 6 once again is positive. So this means that to the right side of this critical value x equal to 2, the slope is positive. So what do we observe? At the critical value x equal to 2, there is a change in sign of slope from negative to positive. And we had discussed earlier that when the slope changes from negative to positive, the critical point in question must be what? A relative or local what? Minimum. So this implies that the critical point which corresponds to x equal to 2, and the critical point is 2, 2 over 3, must be what? A relative or a local what? Minimum. Now, let us sketch the graph for the function. So, our first critical point is this, minus 3, 43 over 2, and the second one is 2, 2 over 3, relative maximum and relative what? Minimum. So, at the point x equal to minus 3, the function increases, or the slope changes sign from positive to what? To negative. That means the function increases to the left, and then between at this other point x equal to 2, the function increases, or the slope changes sign from negative to what? Positive. That means between minus 3 and 2, the function falls this way. And to the right of 2, of x equal to 2, the function has what? A positive slope. That means the slope goes this way. So this is just a rough sketch of the graph of the function we have just dealt with. As an exercise, I'd like you to use first derivative test to determine the nature of extrema of this function, f of x equal to x cubed minus 3x plus 5. And leave your answers in the comment section below. Please do not forget to subscribe to this YouTube channel. Thank you and bye-bye.